Section 4.2, Introducing Permutations and Factorial Notation. So how many different single file lines are there possible when Melissa, Nika, and Francois line up? Okay, so we can have Melissa, then Nika, then Francois. We can have Melissa, then Francois, then Nika. We can have Nika, Francois, Melissa, Nika, Melissa, Francois. Or we could have Francois, Nika, Melissa, Francois, Melissa, Nika. I think there's 6 different ways. There's 2 ways where each of them can be in front. So this is called a permutation. It's an arrangement of distinguishable objects. I'm assuming that Melissa, Nika, and Francois look different. They are distinguishable. For example, the objects A and B have 2 permutations, AB, then BA. So like an example, Naomi volunteers after school at a daycare. Each afternoon, she lines up a group of children in the fountain to get a drink of water. Don't you remember lining up and counting to make sure that everyone got the same amount of drinking time? So how many different arrangements can she create if there are 6 children in her group? So first, we're going to determine the number of arrangements that 6 children can form. So there's 6 positions. You can either be first, second, third, fourth, fifth, or sixth. So there's 6 kids that you can put in that first position. You've already used one of those kids, and there's 5 kids to choose from, 4, 3, 2, 1. And this is the total number of permutations. It's 6 times 5 times 4 times 3 times 2 times 1. So there's a button in your calculator that does this. It's called factorial. So you want to look on your calculator to find the button it's not just an excited 6. It's 6 factorial means 6 times 5 times 4 times 3 times 2 times 1. 21 factorial means 21 times 20 times 19 all the way back to 1. Okay? So what they did is they grouped these. You could either just put in your calculator, you could, well, that's 6 times 5 times 4 times 6, and then you can say that's 120 times 6. So there's 720 ways that you can line them up. Isn't that amazing? 6 kids, there's over 720 ways to line them up. And think of all the budding. Okay, why did they multiply for each position? Okay, and the reason we multiplied, something we talked about yesterday, creating a line involves placing people in specific positions, and placing a person in each of these positions can be thought of as a task. Naomi must place a child in position 1, a child in position 2, and so on to position 6. The use of the connecting word and, because how many ways can I place here and here and here all 6 times? And means fundamental counting principle. Remember, there's the word and in fundamental. Okay? Why did they decrease by 1 each time? Well, because you've used a kid up. And then use n to represent the number of children. What expression represents the total number of permutations possible? It would be n factorial if there was n spots. Okay? Let's move on. Evaluate the following. So this is just calculator work. 10 factorial is going to be 10 times 9 times 8. I'm not going to do that one. I'm going to look at this one. 12 factorial is going to be 12 times 11 times 10 times 9, and it's going to go on. Okay? We're dividing that by 9 factorial, so times 3 factorial. I'm going to do the 3 first. So the 3 is going to be 3 times 2 times 1. And then the 9 factorial is going to be 9 times 8 times 7. So you can see all of these factors are going to cancel out. So really, I have 12 times 11 times 10 divided by 3 times 2. Well, 3 times 2 is 6. 12 divided by 6 is 2. So I'm really left with 2 times 11 times 10. Okay? So this could be done in your calculator, or you could look for things that are going to cancel out. You can do it as well with numbers for all natural numbers. So natural numbers are the numbers you count with. They're the numbers that you can represent with fingers. So this expression is n plus 3 times n plus 2. So simplifying that, this is like n plus 3 is just itself. N plus 2 factorial is n plus 2 times n plus 1 times n. Okay, and it keeps going. Times n minus 1, n minus 2, all the way down to n minus n, or n minus, what am I looking for? All the way down to 1, sorry. Okay, so what you'll notice is this is just n plus 3 factorial. Okay, This one as well, n plus 1 divided by n minus 1. I'll show you what they do in this one. So that's n plus 1 times n. We keep going down by 1. So notice on the bottom is n minus 1, n minus 2. All of these factors are going to cancel out, and I'm left with just n times n plus 1. Okay, we may be asked to solve equations. Here's an example of an equation. N factorial over n minus 2 factorial equals 90, where n is an integer. Okay, so n factorial is n times n minus 1 times n minus 2 times the number minus 3, and goes so on, all the way to 3 times 2 times 1. N minus 2 factorial is n minus 2 times n minus 3 times n minus 4, all the way down to 3, 2, 1. Okay, so all of these are going to cancel out, and I'm going to be left with n times n minus 1. But this was an equation. All of this was equal to 90. So now I have an equation to solve. So this would be n squared minus n equals 90. N squared minus n minus 90 is equal to 0. So I'm solving a quadratic. I have a couple strategies. I could factor. I could use the quadratic formula. I could complete the square. I think I could factor. So I'm looking for two things that multiply to be negative 90 and add to be negative 1. Well, I think I can do negative 10 and 9. N minus 10, n plus 9. So yes, all those things you learned last year, you still have to apply. So in this case, n equals 10 and n equals negative 9. But then we have to check, does this make sense? Okay, n factorial over n minus 2 factorial. So does negative 9 factorial over negative 11 factorial equal 90? Well, negative 9 factorial doesn't mean anything. So no, this we're going to reject. Let's check the other one. Does 10 factorial over 8 factorial equal 90? Well, let's see. So this is 10 times 9 times 8 times 7 all the way 3, 2, 1 divided by 8, 7 all the way to 3, 2, 1. So you can see each of these factors are going to cancel each other out. I'm left with 10 times 9 equals 90 and 90 equals 90. So my answer is n is equal to 10. Okay, couple things. A permutation is an arrangement of objects in an order where each object appears only once. For example, the set of 3 objects A, B, and C can be listed in 6 different ways. So that's like what we did at the beginning, where we had 3 different objects and we showed 6 ways that they can be listed. The expression n exclamation mark is called n factorial and represents the number of permutations in a set of n different objects. And this is how it's calculated. If we have n factorial, the variable n is defined only for values that belong to the set of natural numbers.